So hello guys, today we'll be discussing on the topic Windows forensics. Now the introduction part. So let's see what basically is Windows forensics. Windows forensics refers to investigation of cyber crimes involving Windows machines. It involves gathering of evidence from a Windows machine so that the perpetrator of a cybercrime can be identified and prosecuted. Windows is one of the most widely used OSs. Therefore, the possibility of a Windows machine being involved in an incident is high. So investigators must have a thorough understanding of the various components of a Windows OS, such as file system, registries, system files, and event logs, where they can find data of evidentiary value. Now let's see what is volatile information. Volatile information can disappear or be easily modified. It retains its content while powered on, but when the power is off or interrupted, the stored data is immediately lost. The data is stored in the registries, cache, and RAM of the digital devices. From the forensics point of view, it yields valuable artifacts such as logged on users, command history, shared resources, network related information, information related to processes, information on open files, etc. So let's see some commands. The first is system time, like how to detect the system time. So we will go to command prompt, run as administrator, and type date. Let me maximize it. Type date, then /t, and time /t. So it provides details of the information collected during the investigation and provides an idea of when an exploit attempt might have been successful. So it shows 10th July 2022 and thus today's time. So the next command is nbstat. nbstat sorry, I write the wrong content. tstat minus c. It maintains the list of connections made to other systems using NetBIOS. This command shows the content of the NetBIOS name cache, which contains NetBIOS name to IP address mappings. So you can see local area connection to Ethernet connection, Wi-Fi connection, and the IPs. So let's go to another command, that is netstat. You will see all the TCP protocol, local area address, foreign address, and state in which state is it listening or it established. Netstat tools helps in collecting information about network connections operative in a Windows system. Netstat with -ANO switch that I have written displays details of the TCP and UDP network connections, including listening ports and the identifiers. Now we go to another tool called Task Manager. We here see all the processes, the performance of the system, the app history, like what we have opened, starter, and the users and details. It shows the details of all the name apps, applications that are running behind the system and the services that they are giving. Now the next command is in command prompt. Let me open it. The next is task list. Let me maximize it. As you see, there are so many tasks given on this system. The task list displays a list of applications and services with their process ID for all tasks running on either a local or a remote computer. So it's all the tasks. Now we'll go for next command, and that is ipconfig. ipconfig all. It will give all the connections. It collects information of the network interface cards of a system to know whether the system is connected to a wireless access point and what IP address is being used. And the tools, and there are some more tools used for the network status detection, that are PromSec detect tool and PromQuery tool. Now we will go for non-volatile information. Non-volatile information refers to persistent data which is not lost when a system crashes or is powered off. This information generally resides in the internal hard disk, flash drive, or external hard disk of the system. From the forensics point of view, it reveals valuable artifacts such as information contained in Windows registry, file systems, database files, external devices connected to the system, hidden partition information, etc. Some examples of non-volatile data includes email, word processing documents, spreadsheets, and various related files. So now let's see some commands. We will again go to command prompt. We will go to run as administrator, and we will write the command maximize dir /od. This command basically enables the investigator to examine the date and time of the operating system installation and the service packs, patches, and subdirectories that automatically update themselves often. So you are seeing all the dates with all the OS installations. So it will go on like this, so we can stop here. Now we will go for ESC Database file system. Many Microsoft applications on Windows OS use the data storing technology known as Extensible Storage Engine, that is ESC. ESC is used by various Microsoft managed software such as Active Directory, Windows Mail, Windows Search, and Windows Update Client. From forensics point of view, the ESC database is important because it stores and manages main records pertaining to system and users in Windows OS. The ESC is also referred to as JetBlue. ESC database files are denoted by .edb extension. You have seen that in File Explorer there are many .edb extensions. That is ESC database file only. So following are the examples of ESC database files. Contacts.edb. It basically stores contacts information in Microsoft Live products. WL calendarstore.edb. This stores calendar information in Microsoft Windows Live Mail. Mail.ms message store. It basically stores messages information in Microsoft Windows Live Mail. Windows.edb. It stores index information for like Windows Search by Windows OS. Datastore.edb. It stores Windows Update information local under Windows Software Distribution Data Store. So let me tell you how to use ESC database view. You can view ed.edb files. Let me go for File Explorer, Data D. You have to download this software, ESC database view. You can download from the Google. You can search and go for first link. And let me open it. Your file. You have to use ESC database file. So it is in the Windows. Then you can go to software distribution, data store, and datastore.edb file. So you can open it, and here it goes, and it is all the flags and names of the system. So okay. Now we will go for next, detecting externally connected devices to the system. Detecting the devices connected to a system is an important part of forensic investigation, and it helps forensic investigators determine if any external media has been used by the suspect to commit cybercrime. Investigators can use the driver letter view tool to list all the drives on the system even if they are currently not plugged. Drive letter view is a simple utility that allows you to view the list of all drive letter assignments in the system, including local drives, remote network drives, CD, DVD drives, and USB drives. It also allows one to easily change a drive letter of USB devices and remote network shares, as well as to delete a drive letter of USB drives that is not plugged. One can use drive letter view to export the list of all drives into text, CSV, HTML, XML file, any file. So we go for Windows registry analysis. The Windows Registry is a hierarchical database that contains low-level settings for the Microsoft Windows OS and for applications that use the registry. Investigating the data present in the registry helps forensic investigators obtain information on software installed and hardware drivers configuration settings, track suspicious user activity, determine connected devices information, etc. This information helps the investigator build timeline analysis of the incident during forensic investigation. Hives in the Windows registry play a critical role in the functioning of the system. What basically is Hive? The Hive is a logical group of keys, subkeys, and values in the registry that has a set of supporting files loaded into memory when the operating system is started or user logs in. So we basically see the Hives in the Windows registry. First is FTK users. It contains all the actively loaded user profiles for that system. FTK classes root. This Hive contains configuration information related to the application used for opening various files on the system. FTK current config. This Hive contains all the hardware profiles the system uses at startup. FTK local machine. This Hive contains a vast array of configuration information for the system, including hardware settings and software settings. FTK current user. It is the active loaded user profile for the currently logged on user. So we will go for next, that is forensic analysis of Windows registry. Forensic analysis of Windows registry helps the investigator to extract forensic artifacts such as user accounts, recently accessed files, USB activity, last run programs, and install applications. Investigators can examine Windows registry in the following two methods. It will be static and live analysis. First we go for static analysis. In this method, investigators should examine the registry files contained in the captured evidence file. These files are located in Windows System32 config folder. Now for live analysis. In this method, the investigator use the built-in registry editor to examine the registry and the tools such as FTK Imager to capture registry files from live system for forensic analysis. So next is cache, cookies and history. Examining web browsers such as Microsoft Edge, Google Chrome, Mozilla Firefox, etc. provide crucial evidentiary data such as web history, cookie and cache information pertaining to the user's browsing activity. Cache is basically employed to store the website content for the long run purpose. It stores the contents like HTML pages, images, JavaScript, CSS, etc. Cookie is employed to store user choices and its contents are stored in both server and browser. History. It stores the web pages you have visited on Chrome in the last 90 days. The location of the history and cookies is see user app data local Chrome user data default, and cache location is the user app data local Google Chrome user data default and cache. A tool called Chrome Cache View is used. It is a small utility that reads the cache folder of Google Chrome and displays the list of all files stored in the cache. It displays the information such as URL, content type, file size, last access type, expiration time, server name and server response. A tool called Chrome History View is used. It is a small utility that reads the history data file of Google Chrome web browser and displays the list of all visited web pages in the last days. For each visited web page, the following information is displayed: URL, title, visit, date time, number of visits, number of times that the user typed this address, and the referendum visit ID the user gets when logged into the page. So next is metadata. A metadata is structured data that gives information about certain characteristics of electronic data, including the time and the person that created, accessed and modified the data. It cannot be seen without using special applications, and users can inadvertently share confidential information when sending or providing files in electronic form. Examples of metadata include organization name, author name, computer name, network name, hidden text or cells, document versions, template information, personalized views, and non-possible portions of embedded object linking and embedding objects. It is important to collect this data as it provides information about the following, like hidden data about the document, who right to hide, delete, or obscure the data correlated documents from the different source. Some tools we use are like exif data. Now we view the metadata in PDF. PDF, portable document format, file, contains metadata such as the name of the author, the date that the file was created, and the application used to create that file. The metadata shows that the PDF file was created on Mac OS or it was created by converting a Word document to PDF format. The PDF meta.pl and PDF dmp.pl scripts can be used to extract metadata from PDF files. Now we'll go for metadata in Word documents. Word documents are compound documents based on OLE technology that defines a file structure within a file. Besides formatting information, Word documents can contain quite a bit of additional information that is not visible to the user, depending on the user view of the document. Word documents can maintain not only past revisions, but also a list of up to last 10 authors who edited a file. This has posed an information disclosure risk to individuals and organizations. Perl scripts wmd.pl and OLE.dmp.pl are used to list the OLE streams and trash bins embedded in a work document. Now we will see random access memory acquisition. Examining volatile memory is as important as non-volatile memory. From forensic point of view, examining RAM dumps provides system artifacts such as running services, accessed files, and media, system processes, network information, and malware activity. During live execution, investigators use tools such as Belkasoft RAM capture and Access Data FTK Imager to perform RAM dumps. Now let's see how FTK Imager works.
So guys, let's start with FTK Imager. So to download it, you go to FTK Imager download, FTK version 4.5. FTK Imager version 4.5 downloaded, as I have already downloaded, so you can download it from here. Let me open FTK Imager. Here, so we will go to file, then we will capture memory as we are doing RAM acquisition. So we will capture memory, then we will select the destination path from where we have to this PC. I'm doing in D drive, you can do it anywhere where you want. First let us make a folder. There we can just make a folder first. Folder now, evidence. We'll browse it again. Drive D and look. We will look for the evidence file. Here, evidence file. Then set it OK. We will not change the destination file name. We can change the file name, but we cannot change the extension. It will be MEM only. We will capture memory. We will wait for a few minutes till it is done. It will take few minutes for dumping RAM. Now we can see that the memory capture finished successfully. Now we will check for the file that we have saved it. Data drive D, say the evidence. Yes, it is there. As we cannot send this file directly to the forensic investigator, so we will also send the hash value for it. So to download hash value, we will go for Google Chrome and search the MD5 Windows, because we are doing for Windows, and we for MD5 sums for Windows, and here we will download the zip file. To generate MD5, here it says generate MD5 hashes of files. So we will download the zip file, and we will again make a folder, forensics, download, and we will extract there. Extract files to G drive. Forensics. Then okay. Now let's check for that forensics. Here it's there. You can see the text document. It says how to install that app and some basic commands. Now we will copy this MD5 sum and paste it in the evidence file where we have downloaded the MEM extension file. Now we will go for cmd command to generate the MD5 hash. We will directly go from here, as in cmd command we have to type cd d drive cd evidence, so directly go from the cd command, and we will write MD5 sums and MEM dump. It is a dump file. Now it is generating hash, so it will take some time. It will take few minutes to generate hash. So it is 100% complete. So this is the hash value. We will copy it and we will make a new folder, new text document, say hash, and we will paste that hash here. So hence it is done, and you can set this to forensic investigator. It is a hash document, so no one can easily extract it. Thank you. Hello, welcome back guys. In previous video we saw RAM dump using FTK Imager. Now in this video we will see RAM dump using volatility. So the file we stored in previous FTK Imager was evidence file. So let's go to evidence file, and it was a MEM dump.mem, and the hash we calculated was this. Now we will download volatility first to do RAM dump using. So volatility download. You run volatility 2.6 release, and it's on your system. Every system is using for Windows this link, for Mac, Linux, and if you want to download source code, there will be a zip file. So I will download the volatility link 2.6. You can go window. Yeah, it's downloading. Here the file has got downloaded. Now we will make a file folder for volatility and store that here. New volatility. and downloads, and we will extract that there. Extract files, metadata, volatility, and it will start extracting there. So we'll start. Now we will go to volatility. Here, and we will see this file that we have exported. It is a very big name, so we will remove the additional names, so it will be easy when we use cmd command. Volatile 2.6. Then we have to open the command prompt. We will directly open from it. If we open from command prompt, then we have to download command like cd volatility, then we can directly do from here. We will type volatility minus h for it's volatility minus h. The file volatility 2.6 minus h. And here it goes. It shows all the what type of RAM dump you have to use. How to, these are the commands. We can do anything with these commands. So we have to choose a size dump, small size dump. We can download it from the GitHub. As if we use the pen drive like 6 GB or pen drive, it will take minimum 2 hours to dump. So for basic purpose, we can use the GitHub dump, GitHub volatility memory samples, and this is the first link, and we can download any challenge from this. So we can choose any for Windows. I'm choosing the malware Credex and downloading it. It got downloaded. Then we go to downloads. Download here. It is Credex. I'm making a folder and I will extract there. So I am making a folder named dump, and I will extract there. Downloads, text, extract files, D drive, and dump. So if you download it, we will go there, dump. You will see a .vmem extension file is downloaded. We will copy this file and paste in volatility. We will paste it there. Before it was volatility 2.6, so it was being difficult for using the command prompt, so I changed the name to simple volatility. Now we will open cmd and we will write again volatility minus h for seeing the commands. Here we can perform these activities. For now I am using the image info to find the image of this dump, information about this dump. So writing the commands, volatility minus f, then we have to write the file name, minus f for his file name. The file name is credex.vmem. So credex.vmem VMEM, then we will write the image info. We have to calculate the information about the file. So it will take 10 to 15 seconds and give the information. And determining profile based on KDBG. It will give the information when the image was found and on the which profile. So it has given that the suggested profile is WinXP2 into 86 bits, and the number of processor it using one, image type is 3, service pack is 3, and all the information like image date and time when it was created at 22/7/2012, and local date and time is 21/7/12. So we will perform other commands like let's do cmd scan. It extract the command history by scanning for command history. With the command history what all commands were performed. Yes. So it's volatility minus L, then the file name, and then the profile we have for specific profile. The profile I'm choosing is WinXPSP2 into 86 bits. 86, and we are doing the CMD scan. So CMD scan. It says what commands were done in this disk. So we can use many options like it is given -H for help, -J for debugging, -in1 for giving the information for cache. And there are many, like we have, if on forensic investigation, like how we want to search, we want to see the connection, it will list all the connections that have been established on that disk on that RAM, and the console, the crash info, the how many information on the crash dumped information, and all the DLL list. It will scan the files, and many hash dump, it will dump password hashes. It will be LM or anti-LM from memory. Hive dump, it will print out a hive dump. So many options like in volatility. So thank you.
Now let's see what a file system in Windows. File system is a collection of algorithms and data structures that perform the translation from logical file operations to actual physical storage of information. In computing, a file system determines how data is stored and retrieved. Without using the file system, information placed in a storage medium would be one large body of data with no way to know where one piece of information stops and the next one begins. The four file systems supported by Windows are REFS, NTFS, FAT, and EXE-FAT. So let's see what is REFS, that is Resilient File System. The Resilient File System is a new file system built from scratch by Microsoft. Since it is a new file system, it requires Windows 8 or Windows Server 12 in order to operate. The main design difference between it and previous operating system is that it is designed to fix problems while the operating system is online. For this reason, the check disk feature that is found in previous operating systems that can be run to fix problems no longer exists. Given a new approach has been taken in the operating system, it is better at ensuring data integrity and corruption than previous operating systems. Now let's go to next, NTFS, that is New Technology File System. This file system was first introduced in 1983 with Windows NT. It differed from the previous operating system in that it supported security. It also has additional features like compression and encryption. File systems like NTFS, REFS and Linux system ext3 uses a transaction log. When changes are made, these changes are stored in a log file before being returned to the drive. This does slow the drive down a little. However, it makes the drive less prone to data corruption and data loss, in particular during the power outages. Since NTFS has been introduced, there have been many different versions of NTFS offering additional features. Features like self-healing have been added. However, these are limited to what they can do due to their limitations by original design. So we will next go to FAT, that is file allocation table. The file system FAT was first introduced in DOS, the FAT32. The FAT32 system that is found in modern Windows is an improved FAT system of the original FAT file system. Since FAT has been around for such a long time, it is compatible with almost all operating systems, including the alternative operating systems. It does not offer additional features like security, compression or encryption. Since it is a basic operating system with a lot of compatibility, it is often used in removable media, for example USB thumb drives. Now let's see what is EXFAT, that is Extended File Allocation Table. This file system was created by Microsoft. For this reason, it is a proprietary and patented. In order for devices like a TV to use this file system, they need to pay Microsoft a fee. Supported for it is available in Windows XP and above. However, you may need to apply some updates in Windows XP to use the file system. The file system itself was not designed to be used as a replacement to NTFS or other file systems, as it does not support features like file compression and encryption. The file system itself is optimized for flash drives. When comparing it to FAT32, it supports big drives and often offers better performance. However, is not supported on the many device or operating system. So let's see the summary what we have learned in this Windows Forensics. So in this module we have learned about volatile information, non-volatile information, ESC database file, how to detect externally connected device to the system, Windows registry analysis, cache, cookie and history, metadata, RAM execution using FTK Imager and volatility, and different file system in Windows. Thank you. Hope you like my video.